Welcome to Long's edition of this week's coffee break. Appreciate you joining me today. My name is Andrew Schmidt. Let's see if the slide can actually change here. Goodness sakes. Here we go. So today I'll be introducing Daikin's R32 VRV system, but when I was kind of going through these slides, I thought it would actually be very valuable to just kind of go over some tidbits with the recent A2L codes and standards for VRF. So I'm also going to be reviewing that. My name is Andrew Schmidt. I am on the VRV team here at Long and a sales engineer on that team. So first, I'd like to just use a couple of slides to talk about the differences between the different A2L refrigerants that are available. The big common ones are R32 and R454B. I know there's been a lot of information that's been given out there as sort of like a competition between these two, but that's not how Long looks at it. In fact, we represent manufacturers that have equipment that uses both of those refrigerants. So the main thing is that the refrigerant needs to have a GWP, a global warming potential, that's less than 700. And you can see that both R32 and R454 meet that goal. So some of the differences are highlighted between R32 and R454B here in this table. They compare it back to R410A, as you can see. The global warming potential is slightly different between R32 and R454. What I do want to highlight is R454B. About 70% of the content of that is R32. The other 30% is a refrigerant called R1234YF. That particular compound has a much better global warming potential. And so when you put those two together, you bring down your overall global warming potential to 466, as you can see here. The R32 refrigerant has better performance characteristics compared to R410A, as you can see with the capacities and efficiencies that are shown here in this table. So R454B has a slightly better efficiency than R410A as well. But if you're thinking about the global warming potential, what's interesting is when you kind of look at the fact that you can have up to 40% smaller refrigerant charges. Due to that, because you're using less refrigerant, the overall effect on the environment, as you can see in the table over to the right, is basically the same when you look at the life cycle climate performance of the two refrigerants. So they're pretty much equivalent in terms of the environment performance. So as you know, Daikin went with R32 for their A2L choice, and that's basically due to the fact that there's already 200 million units installed across the globe. The rest of the world was kind of ahead of us in terms of using better GWP refrigerants. They started earlier than we did. And so just using that experience and that installed base, it just made sense to use R32 for Daikin. So just a real quick comparison. Because of those better performance characteristics of R32 compared to R410A. This is just a real quick sample I brought up here, but it's comparing the R32 equivalent mini split to the R410A equivalent that Daikin previously manufactured. And in all cases, you can see that performance increased across the board slightly due to the better characteristics of the refrigerant. So moving on to the codes and standards portion of the talk, I just wanted to bring up kind of three main things that you should kind of keep in the back of your head during the rest of this talk. One are refrigerant sensors, and then second is recirculation mode for fan coils, and then finally third is isolation valves built into BS boxes, and that's used to get around some of the rules in the code. So as it stands today and how we've been designing systems in the past, it's been pretty black and white, cut and dry in terms of how we do that. Our only constraint that we look at is something called RCL, refrigerant concentration limit. And as we all know, that's 26 pounds of R410A per 1,000 cubic feet of volume of your smallest occupied space that is served by a VRF or VRV system. So it's fairly cut and dry in how to comply with that. You just have to be equal or less than 26 pounds per 1,000 cubic feet. So now, moving forward, if you look at ASHRAE Standard 15 2022 version, which does discuss A2L refrigerants, the first thing that kind of pops out when you're looking at this is the RCL value of R32 and also R454B are considerably smaller than R410A. And you can see here it's 4.8 pounds per 1,000 cubic feet. That really restricts what we can do in terms of what's the smallest size space that you can serve, because charges are generally much greater than that. So moving forward, instead of looking at it just from an RCL perspective, now we're going to be looking at it from EDVC perspective, which is the effective dispersal volume charge. That's calculated, and that will no longer need to look at the RCL anymore. You use the calculation shown below, but in short, you'll look at the MREL, which is a releasable refrigerant volume. That has to be less than or equal to that EDVC. So keep that in mind for the next couple of slides that we're going to go over here. So as it stands today, and as it was before, we use 26 pounds per 1,000 cubic feet. And again, fairly cut and dry. We just designed our systems around that smallest occupied space. And then when we were not able to comply with the 26-pound constraint, we had two options. We could reduce the concentration level or increase the dilution volume to get around that constraint. So for the first method, which is reducing the concentration levels, the easiest way to do that is by just making a smaller system. So instead of having, let's say, a 20-ton system that's serving 20 different indoor fan coils, cut that in half. Now have two 10-ton systems that each serve 10 fan coils. That's kind of the easy button for making your refrigerant volume go down. And then if that didn't handle it, then we could move over to, like, say, a single phase system that typically have much smaller overall refrigerant charges. And then finally, if that didn't do it, we would just use a 1-to-1 mini split to serve like a little electrical room or something like that, or a closet. So then the other method, besides just decreasing the refrigerant charge, is increasing the dilution volume, the overall space that you're serving. So there's tricks of the trade that, I'm sure we've all looked at, which is things like, using transfer grills or undercut doors or false ceiling plenums, things of that nature. However, there is, I would say, some gray area when doing that. And you can see here in the gray box, I won't read that, you can read it yourself, but basically it was asked, like, how do we interpret this? And their response was, look, that's kind of up to you and the AHJ of your local jurisdiction. So it's certainly some gray area, but that's how we handled it. So now moving forward with A2L refrigerants, we're hamstrung with this extremely low RCL, 4.8 pounds per 1,000 cubic feet, right? Well, the first way to increase that is what's been published in ASHRAE 15 2022, is if you can detect that leak on the system, and if you can mitigate it, which is turning on a fan and dispersing it throughout that space, you get to drop this 0.5 coefficient in the formula, and now you're at 9.6 pounds per 1,000 cubic feet. Doubled from before, but still not quite enough to be able to design an effective system. So this is the main point of what kind of saves us, is using isolation valves. So all the manufacturers, including Daikin, are going to put isolation valves in their branch selector boxes to effectively cut up a system into separate isolatable zones. So let's say you have a 8-port box, instead of, and it has a total refrigerant charge of 100, you divide that by 8, and now your refrigerant charge is only 12.5 pounds per zone if you divvy it up equally. So that's what really allows us to now have freedom to design systems of same size of what we've been designing with our 410A. So then now if you look at ASHRAE 15, and as it stands, if we follow ASHRAE 15 in 2022 version of ASHRAE 15, that is, we're going to have to use ventilated shafts. And so when I first saw this, along with my sales partner, Jeff McBride, we're like, okay, we might need to look at doing something else to support our family here, because how in the heck are we going to sell any VRF systems with requiring to use ventilated shafts? Well, luckily, there is an addendum AE, it's called, and I've got a snippet of it here, and this isn't official yet. This has been accepted, but it hasn't been published yet in the latest version of ASHRAE 15 2022, but it has been accepted. But it will allow us to be able to design buildings that are not requiring ventilated shafts when placing refrigerant piping with A2L refrigerant in them. So that's great news. So now I want to just talk a little bit about the city of Denver. So just recently, just last week on 10/23, this document was published. I encourage you all to go out to the city of Denver's code page and download this. You can also contact me and I can send you a PDF of this. But as you all know, city of Denver follows IMC code, which is now in 2021, but that code is way behind the 8 ball in terms of design for A2L refrigerants, and the city of Denver realizes this. So now moving forward with this document, we can now use ASHRAE 15 2022 and ASHRAE 34 2022, and those will now be acceptable in place of IMC 2021 Chapter 11, which is great news. And then also with the previous slide that I showed, addendum AE will also be accepted. It basically says that any changes to these ASHRAE 15 and ASHRAE 34 will also be followed. So now I just want to introduce VRV-S, which is Daikin's first VRV product lineup that uses an A2L refrigerant. So just kind of keeping in mind, this new product lineup does have the refrigerant detection systems. It does have the safety shutoff valves. It uses all of those features to be able to design with A2L refrigerant. So this is just kind of showing, it does have the refrigerant sensor. It's going to be in all the different fan coils that are available. And at market release, when these are available for sale in January 2025, there's going to be all the common fan coils, like the vertical furnace style air handler type fan coil, as well as a medium and high static concealed ducted fan coil, and then finally like a 3x3 cassette. So again, these will all have this refrigerant detection system within it. If a leak is detected, a buzzer will go off, an alarm like in the room to notify any occupants of the space to leave. Then the fan will turn on and go into that ventilation mode to mitigate, like we talked about earlier. And then finally, a signal will be sent to the BMS, an alarm code showing that a refrigerant leak has been detected. Oh, and then another thing I wanted to talk about was just the safety shutoff valves that we talked about. The VRV-S, the single phase product lineup here, only is available in heat pump version. So you don't have branch selector boxes, which is where I said previously that the safety shutoff valves would be. There's still going to be safety shutoff valves, but they'll be placed in the piping. So maybe right next to your fan coil, they'll be placed and then be controlled by the fan coil. Not all the details have been released yet, but we will have the ability to zone out systems like described before. So this slide is just basically showing as soon as a leak happens, it goes into the dispersion mode, which just mitigates and moves around the refrigerant to allow us to have an RCL of 9.6. which basically effectively doubles the space that you can serve. And these are the different fan coils that I just told you about previously. Right now, out of the gate, it'll be these 3 different styles, but as time goes on, all the other fan coils that aren't used as often will also be released. I think the biggest improvement with this lineup is now we're going from a 3 to 5 ton lineup. Well, now we're going down to 2 ton. Well, that's great. But then the other side of it is the 4 and 5 ton. They used to be the double suitcase style size that you see here. They're all just this single suitcase style form factor, and that's due to the higher efficiency of R32 compared to R410A. So they're actually able to compact the size of the units now, which is great. So appreciate you guys dialing in today. This was a lot of information in a very compact format. Please contact myself or Jeff McBride. We're currently scheduling kind of a blitz to the local engineering community here for lunch and learns, or say breakfast presentations, or just middle of the day presentations, to do a longer deep dive into the code interpretations. So please contact us. We'd love to schedule something to come out to your